Hey, how are you guys doing today? All right, if you will look, you got skeleton notes for this lesson. I think if you use them, it'll make it easier for you to follow along. Remember, the beauty of recordings is that if you ever want to pause so you can catch up in your writing or rewind so you can hear something again, do that, okay? That's the one good thing about having to sit at home with the recording. All right, so we did a little synthetic division yesterday. Now we're going to go forward. And so I'm going to do these two problems with you, and then we'll regroup. So let's practice our synthetic division. Remember, if the factor is x minus 3, then with the synthetic division, you actually divide by x equals 3, okay? So I'm going to say 3 down and over when I'm doing synthetic. I've got 3x to the fourth, negative 1x to the third. I'm looking for if I need placeholders, but it's going 4, 3, 2, 1, 0. So I haven't skipped any spots. Negative 25x squared minus 1x and plus 18. So here we go. Whatever this number is, bring it down. Then we're going to multiply and add and multiply and add. So here we go. 3 times 3 is 9. 9 and negative 1 add up to 8. 3 times 8 is 24. Negative 25 and 24 add up to negative 1. 3 times negative 1 is negative 3. Negative 1 and negative 3 add up to negative 4. 3 times negative 4 is negative 12. 18 and negative 12 add up to 6. Box that last one in. That's your remainder. Okay, so that tells me that my answer is, let's see here. Remember, this is your ones, x's, x squareds, x cubes. So 3x cubed plus 8x squared minus 1x minus 4, but I have a remainder. So that's where I say plus, and I write the remainder over what I divided by. So technically I divided by the factor x minus 3. So this is my mixed fraction format. I know that x minus 3 is not a factor of the original big quartic polynomial. That goes along with saying then that x equals 3 is not a solution. SOLN's the abbreviation of solution. So if I had set this big polynomial equal to 0, then x equals 3 would not have been a solution of that equation. So one result I can write, remember, is that the original polynomial can be written as, all right, what I divided by, which was x minus 3, what I got, which was 3x to the third plus 8x squared minus x minus 4 plus a remainder of 6. So if I actually took the time to multiply all that out and add the 6 back on, it would come back to the original. That's not something that's quite as necessary when the remainder is not 0, but when the remainder is 0, we are really going to use that. Here's our second example. So we are dividing by x equals negative 1. That's the same thing as thinking about dividing by the factor x plus 1, because we'll go back and forth between those two. So I'm going to say, let me say negative 1 goes into 5x to the fourth, 9x to the third, 2x squared, 5x, and 7. So I noticed that I didn't need any placeholders, no zeros to stick in there. Bring down the 5. Negative 1 times 5 is negative 5. Bring down 4. Negative 1 times 4 is negative 4. Add these and get negative 2. Negative 1 times negative 2 is positive 2. Add those and get 7. Ooh, I like this one. Negative 1 times 7 is negative 7. Box in your remainder. Oh, I like this one. So let's talk about what we know. Your answer is, let's see, 1's, x's, x squareds, x cubes. So your answer is 5x cubed plus 4x squared minus 2x plus 7. All right, there's nothing out here, so no remainder thing out here. All right, so that means, since I got 0 remainder, it means that x plus 1 is a factor. It divided in evenly. And that means that x equals -1 is a solution if I had been solving an equation. So if I set this equal to 0, it would be a solution of that equation. So the other thing I know is that I have the result that 5x to the 4th plus 9x to the 3rd plus 2x squared plus 5x plus 7 is equal to the factor that I divided by. So remember, I said I divided by x equals -1, but in factor form, it's x plus 1 times what I got, and what I got's right here, 5x cubed plus 4x squared minus 2x plus 7. So ultimately, guys, this is quite helpful because we are trying to factor big old polynomials, because once they're factored form, we can solve them. So now we're going to do a couple of problems where I'm showing you synthetic division and what's called the remainder theorem. So we'll do this problem together, and then we'll do this problem together. All right, so here's our first problem that we're going to do. Now, if I want to evaluate directly, then I do that by substituting in. So I'm going to use direct substitution. So p of -3, since I've got this p of x equals function form, remember this is just a fancy way to say y equals this. And if you have an equation equal to 0, it means you're solving. If you have an equation equal to y or some function notation like f of x, g of x, q of x, then it means that you're getting set up to graph. So anywho, if I want you to evaluate directly, it's saying p of -3 means plug in -3 for x. So I'm going to say p of -3 equals 2 times -3 cubed. And if you say -3 times -3 times -3, that is -27, minus 3 times -3 squared. -3 times -3 is 9, minus 32 times -3 minus 15. So I'm going to work on my calculator in just a moment. So that's -54, that's -27. That looks like positive 96, and then minus 15. So I'm going to work with my calculator. I wish that you all could see my calculator really clearly, because there's some things I want to show you, but my virtual calculator right now is not working either. Hopefully they're fixing that. Oh, awesome. On that one, I punched that into my calculator and I got 0. So now I can say, oh, p of -3 equals 0. Now, I want to show you what some things that means. That means the point -3, 0, where -3 was my x, 0 is the y I just got, is on the graph of p of x. So we are going to be graphing these things in a day or two. That's one thing I know. Since -3, 0 is on the graph, I can say, remember, that would be on the x-axis. So that means -3, 0 is an x-intercept. So that means x-intercepts are also known as roots. Roots are also known as zeros. Zeros are also known as solutions. So all of these words are interchangeable. So if I'm talking about solutions, I can also say that means x equals -3 is a solution. Oh, that means x plus 3 is a factor. So that means x plus 3 would divide in evenly if we were to do synthetic division or long division, which is what I'm going to show you, okay? But I want to connect all these things because this is the big idea for this chapter. So let me now show you. Now I'm going to erase some of the big ideas that we just got, just so I can make room here. Now, I said, don't only evaluate directly, but also evaluate synthetically, which just means use synthetic division. Sometimes you'll see people say evaluate synthetically, or evaluate with synthetic division, or evaluate with synthetic substitution. If you hear the word synthetic, it all means the same thing. Just some textbooks, some math teachers say something slightly different. So what I'm going to do is I'm going to say -3. And I'm going to go ahead and say 2, -3, -32. And I see -15. Bring down 2, multiply, get -6. Bring down -9, multiply, get positive 27. Bring down -5, multiply, get positive 15. Remainder of 0. Now, I expected that because I just mentioned that if x equals -3 is a solution, then x plus 3 is a factor, and factors divide in evenly. But guys, even if you didn't do the evaluate directly, the remainder is the same as the y-coordinate. So that's the idea of the remainder theorem, is that the remainder is the same thing as you would get for the y-coordinate of the point. So I'm saying if x equals -3, the y that goes with it is 0. And there again, you're saying that -3, 0 is a point that's a solution, or a root, or a 0, or an x-intercept. So those things go together. So let's do the same process for this next one. So if I do direct evaluation or direct substitution, whatever you want to call it, then I'm going to plug in. So I'm going to say g of 1 equals 1 to the 4th, which is 1. 1 squared is 1 times -11. 6 times 1 plus 2. So that's equal to -10 plus 8. So -10 plus 8 is -2. All right. So g of 1 equals -2, which means the point 1, -2 is on the graph of g of x. All right. 1, -2 is not on the x-axis if you plot that point. So 1, -2 is not an x-intercept. So if 1, -2 is not an x-intercept, then x equals 1 is not a root, a solution, or a 0. So I'm just trying to get you to connect root, solution, 0, x-intercepts. Essentially all mean the same thing. So don't feel like it's always a new problem. It's just different vocabulary for the same kind of idea. So that also means that x minus 1, if x equals 1 is what we're testing, x minus 1 is the factor, but x minus 1 is not a factor of g of x, which means if I do division, I am not going to get a remainder of 0. So speaking of division, let's look at the method where we use synthetic. So this time I'm going to take 1, and I'm going to say 1x to the 4th minus 11x squared plus 6x plus 2. Again, I'm looking at the original equation. So bring down the 1, multiply 1 by 1 and get 1. Bring down -10. Multiply 1 by -10 and get -10. Bring down -4. Multiply 1 by -4 and get -4. Add these and get -2. So look, you got -2 here. Remember, the remainder theorem tells you that the remainder, when you do synthetic or long division, but most of us are going to do synthetic because it's faster, is equal to the y-coordinate. So it's telling you if you plug in x equals 1, you get y equals -2. Therefore, we're dealing with the point 1, -2 on this graph. Now, this is not a real good result because you're always in search of a y-coordinate that's 0, because then you would have a point that's on the x-axis. So you get an x-intercept, a root, a solution, a zero, or a factor. That's what we're searching for. So you've seen a good one, and now you've seen a not so good one. Now, we're going to use what we've just been working on, and we're going to start tying together ideas. Why are we doing this? Well, we are either trying to graph equations, which means we need the x-intercepts or roots or zeros or solutions to do that, or if the equation's not equal to f of x or y or h of x or some other thing like that, the equation will be equal to 0. Either way, what we're doing is the same. So we're going to do examples 5 and 6 right now. All right, so our first problem. My goal is for you to okay, I went away for a minute because my camera got fuzzy. So my goal is for you to completely factor f of x. If you know the factors, you'll instantly know the solutions. Later, we would take those solutions and learn how to draw this graph. All right, so this corresponds to if this were set equal to 0, solving the equation. So f of -5 equals 0 tells me -5, 0 is on the graph. Since that's on the x-axis, I know that's an x-intercept. If that's an x-intercept, I know x equals -5 is a solution. If x equals -5 is a solution, I know that x plus 5 is a factor. And if I know that x plus 5 is a factor, I know when I do division, I'm going to get a remainder of 0. So I'm going to do division. I'm going to do synthetic division specifically. So I'm going to divide by -5 because we're looking at x equals -5. I'm going into 2x cubed plus 23x squared plus 41x minus 20. I'm going to bring down 2, multiply, get -10, bring down 13. Multiply, I believe that's -65. Let me check. 5 times 13 is 65. Yep. And I'm going to subtract 41. So I'm going to bring down negative. Pause. I'm going to see if something's wrong with what I've printed. Found the mistake. It was supposed to be -120 and not -20. But -5 from -24 times -24 is 120. I knew there was a problem, so I'm glad I fixed it there. All right, guys. So now what I know is that f of x, after you do synthetic division, you always come back and say, well, where are you in your factored form? Well, I just figured out that x plus 5 is a factor, so put it first. Now, the factor that I multiply it by is, remember, zeros or ones place, x is x squareds. So times 2x squared plus 13x minus 24. Now, what I want to do is see, can I factor this further? Well, this is a quadratic. So when you get to the point of having a quadratic, you don't do synthetic division anymore. You just do regular factoring. Well, there's no GCF, so my regular factoring would be AC method because I see 3 terms. So I'm going to stop and work on the AC method. So let's see. I see that AC is 2 times -24. That's -48. So I'm doing scratch work here. And I'm thinking 1 and -48, 2 and -24, 3 and 16. So is it 3 and 16? It needs to be positive 13. So I better make 16 positive and 3 negative. So now what I'm going to do is say, let me right quick do 2x squared minus 3x plus 16x minus 24. So here my GCF is x times 2x minus 3. Write down the positive sign. 16 and 24, 8 goes in. And I know it needs to be times 2x minus 3. Check. That gives you 2x squared, minus 3x, plus 16x, yeah, minus 24. So things are fine. So now I can write this part. It's 2x minus 3 times x plus 8. Now what I'm going to do is say that f of x, so I come back to this because this is the problem that I'm working. F of x is equal to the x plus 5 I already had, times the 2x minus 3, times the x plus 8. Now all of these are to the first power, so they can't factor further. I'm done. Now one thing I check to make sure that I haven't somehow or another lost part of my pieces is if you look at x, 2x, and x. That multiplies out to 2x to the third. And look, your original problem led off with 2x to the third. So that means you haven't lost any of your pieces or parts. So I always check that. Now, if I say f of x equals, that means I'm graphing. And that tells me that the points I ought to put on the x-axis are -5, 0, 3/2, 0, or -8, 0. So those would be my x-intercepts that I would put on my graph, okay? Now let me say it a different way. If instead I said this is equal to 0, so you were naming solutions, I would say that x equals -5, x equals 3/2, I said y, I meant x, or x equals -8 are the solutions. Now remember, solutions are the same thing as roots, and they're the same thing as the zeros. Just FYI, I tend to say roots, but if you look at your calculator, when we look at calculator stuff later, the calculator calls them zeros. So we're going to completely factor g of x. It'll be a similar process, but with one extra thing that you need to know. But guys, remember, here's your hint. This is the same thing as saying that x equals 4 is a solution or a zero or a root. That also would mean that 4, 0 is an x-intercept on the graph. So remember, those are all interchangeable terms. So I am not going to use this first, because if I want to factor g of x, the first thing is always GCF. And I notice that x is a GCF. So I'm going to start out by saying g of x equals x times 4x cubed minus 12x squared minus 19x plus 12. Now, normally I would say don't even think about synthetic division if you can regular factor. There are 4 terms. And if I'm going to regular factor, I would have to do 4 terms by grouping. But if you look, don't worry about signs for a minute. Here I have a ratio of 4 to 12. And for these two, I have a ratio of 19 to 12. Those ratios are not equal, which is telling me grouping is out. I always check to see if it'll group or do AC method first, but I can see quickly I cannot. So I'm going to use the idea that x minus 4 is a factor, which means I can do division and get a 0 remainder. Well, I want to divide using synthetic because it's faster. So my synthetic division is going to be with x equals 4. Notice I'm keeping all my steps in line vertically. So that's going to keep your work the most organized and the most tight on your paper. And you might say, by the way, you're using 4, -12. You might think that keeping your work tight is no big deal. But what happens is when you start getting spread out, number one, I can't follow you. And then I'm not going to give you maximum credit. And I want to give you maximum partial credit. But the other thing is when you get disorganized and your work's all over the place, you start losing track of where you are in the problem, and then you won't know what to do next. So bring down a 4. 4 times 4 is 16. Add those and get 4. 4 times 4 is 16. Add these and get -3. Multiply those and get -12. And you get 0 here. Yay. All right, so now where am I in the problem? Always go back up. Remember, right after you do synthetic division, you always come back to factored form. So come back up and notice you'd already factored out an x. Now, your baby factor, because 4 worked, remember you've got a baby factor of x minus 4, so don't forget that. And now you've got this new factor here. So I need to say 4x squared plus 4x minus 3. And now I need to keep factoring. This is quadratic. So once you hit the point of quadratic, you're going to try regular old AC factoring. So you don't go back to synthetic division once you get to the point of having a quadratic. So when I look at this, AC is negative 12. And I want 4, so I'm thinking 6 and 2. Can I make that happen? Could you do positive 6 times negative 2? Yeah, you should be able to. So I'm going to say 4x squared plus 6x minus 2x minus 3. So here I'm getting 2x times 2x plus 3. Bring down the negative. 2x minus 3, there's no GCF, so it would just be 1 times 2x plus 3. Check. That's 4x squared. Plus 6x. Minus 2x. Minus 3. So I'm on track. I'm going to make this 2x plus 3 times 2x minus 1. Now, come back, because what you're trying to do is give me the factored form for g of x. So g of x equals x and x minus 4. Don't forget, you already had those. Now put your 2 new little factors in, 2x plus 3 and 2x minus 1. These are all now linear, meaning they're all to the first power, x to the first power, so you're done factoring. So remember my trick to make sure you've not lost any of your duckies as you've worked through the problem, because sometimes you will without thinking about it. If I say x times 2x times 2x, that gives me, let's see, 4x squared times x squared is 4x to the 4th. And yes, 4x to the 4th is what I had. So that helps me remember I did not lose any of my ducks as I went. So being super organized is super helpful on this. So now, if I said, what are the x-intercepts? You would say, well, x gives you 0. X minus 4 gives you x equals 4. 2x plus 3 gives you x equals negative 3 over 2. 2x minus 1 gives you x equals 1/2. So these would be the solutions or the roots of the equation. And if you were graphing, you would plot 0, 0, 4, 0. Am I out of bounds now where you can't see what I'm doing? See if I can do that. It would give you negative 3/2, 0 and 1/2, 0 on the graph. Today we're just naming, we're not graphing, but I am trying to get you ready for graphing later. So now I need to show you what's called the rational root test. Some people also call it the rational root theorem, and I just always call it the RRT, because there's one piece of this puzzle that you have not seen, and that's what we need to talk about. So I'm just going to show you how it works on 7 and 8, and then we'll do the whole enchilada when we get to problems 9, 10, and 11. All right, so if I ask you to solve this equation, and I did not give you a hint, all right? Furthermore, notice that the numbers 1 to 4 and the numbers 10 to 4 are not the same ratio, so grouping's out. But notice I haven't given you a hint. I haven't told you what one of the solutions or one of the factors is to get you going with synthetic division. Well, the rational root test is what gives us a connection and tells us where to start looking for that hint, okay? So the idea is that you take the leading coefficient and you take the constant term, and I create a fraction. So I'm going to look at the factors of the constant term. So the factors of the end number over the factors of the leading coefficient, which I abbreviate LC. So the leading coefficient is your beginning term. And so I'm going to say what all goes into 4. Well, 1 goes into 4, 2 goes into 4, and 4 goes into 4. What all goes into and understood 1? Just 1. All right? That produces a list of things to try. So I'm going to say, all right, I'm going to try plus or minus 1 over 1, plus or minus 2 over 1, and plus or minus 4 over 1. So that tells me that I've got 6 different numbers that I need to try. What do I mean try? I mean plug them into this equation, and what you want to see is, do any of them give you 0? Well, let me show you the fastest way, and I'm hoping that you might be able to see this. Yeah, that worked. So I plug this into y1. All right, you do the same. Pause the video if you need to. Now, let me show you on your settings something that will help you. So go to second, table set, and you can start the table anywhere. But the big thing is you want to do set independent on ask and dependent on auto, okay? So now go to your table, and it's going to help you build the T-chart so you don't have to do all this by hand. Well, I wanted to try 1 and -1, so I'm just going to go in order. So if I plug 1 in for x down here, hit enter, it automatically gives you a y, and that y is -9. So now plug in -1 for x, and y is +9. Now I also wanted to plug in 2 and -2. So if I plug in 2, I get -24. When I plug in -2, I get 0. So now that's what I want to use. So we've created our own hint. Our own hint would be that x equals -2 gives you y equals 0. So that means x equals -2 is a solution, a root, or a 0. So any of those words that you want to use, there we go. All right. So let's try the other one so you can see more about the rational root test. I'm not going to finish this problem. I just wanted you to see it get started. Okay, so I want you to solve this equation. To solve the equation, you've got to completely factor it. I don't see a GCF, and I notice 8 to 26 is not the same ratio as 5 to 3, so grouping's out. If I can't just factor it by grouping, I need to use synthetic division. But I don't know what to start with. That's what the rational root test is for. It tells you, try these numbers so you can figure out where to start. All right, so I'll look at the factors of the constant term, so the factors of 3, over the factors of the leading coefficient, so the factors of 8. I'm going to get fractions this time. All right, so what are the factors of 3? Well, 1 and 3 are the only numbers that go into 3. What are the factors of 8? 1 goes into 8, 2 goes into 8, 3 does not, 4 does. And once you get to 2 times 4, you're starting to actually repeat yourself in a way, so 1 times 8. What's that mean? That tells you the numbers that are worth trying on your calculator, like I showed you a minute ago, are 1 over 1, 3 over 1. So you take every possibility of top over bottom. So now I've done the 1s over 1. So now I've got to do 1 over 2 and 3 over 2. So now I've done the 1s over 2. So now I've got to do 1 over 4 and 3 over 4. And I've done those. So now I've got to do the 1s over 8. So 1 over 8 and 3 over 8. Ooh, that's a long list. So 2, 4, 6, 8, 10, 12, 14, 16. Yikes, there are 16 possibilities. And it could be that all 16 don't work, but that would be a lesson for another day. So on today, you're going to find one that works. So what I need you to do is plug the equation I gave you into Y1, okay? Now, table set should already be ready. You always want the independent, which means your X is to be on ask, and the dependent, which means your Y is to be on auto. So you're going to plug in the X's and the calculator will automatically spit out the Y's for you. Cool, huh? So go to your table. So second graph takes you to your table. So this time, remember, if you need to plug this in, just pause me and then start again once you get it plugged in. I need to try 1 and -1. So 1, -1. Neither one of those are giving me 0. So try 3 and -3. So 3. Ah, that does it. When I plugged in 3, I got a 0. Stop. Now I know that X equals 3 gave us Y equals 0. So that is where you start. So you would now do what you would go through now with algebraically is do synthetic division with X equals 3. Now, I'm not going to work through the rest of the problem. I just wanted to spend a minute showing you how to use the rational root test and the calculator. So now, guys, we're gonna bring it home. We are building the whole enchilada. So we're gonna do problems 9, 10, and 11, and you're out. So what I want to do is completely factor this and name all the roots, the zeros, the solutions, the x-intercepts, any of that. Now remember, it's basically the exact same thing you do if it were equal to 0. Here I would say solve, but it's the same thing. You would factor and then you would find all the roots or the zeros or the solutions. So guys, either way I go, when it's g of x equals, it means that we're going to solving graph. If it's just equal to 0, that means you're solving and stopping. Either way, today we're solving, we're not graphing yet. Okay, so I look at this and there are no greatest common factors. You pull out a greatest common factor first. Now, typically, I would say if it groups, we're going to group it. And this, in fact, does group. Because look, 4 to 32 and 1 to 8 actually are the same ratio. If you reduce 4 to 32, you get 1 to 8. Typically, I would say we are going to group it then. But today, since what I'm trying to show you is the rational root test and synthetic division, I'm not going to group it. But in a couple of days, when I pull all this together, I would group this. So just keep that in mind. So I'm thinking, oh, I need to do synthetic division, but oh my, what should I do synthetic division with? So what do? The rational root test. So the rational root test tells me to look at the factors of 8 over the factors of 4. Okay, so the factors of 8 are 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. The factors of 4 are 1 goes into 4, 2 goes into 4, 4 goes into 4. So the list I get of numbers I need to try are 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So just 1, 2, 4, and 8. So I'm going to mark that off. Now, I also need to look at everything over 2. So 1 over 2, 2 over 2, 2 over 2 is 1. It's already in the list, so don't put it in the list again. 4 over 2 is 2. It's already in the list, so don't put it in the list again. 8 over 2, ditto. It's 4. It's there. So 2's done. Yay. 1 over 4. 2 over 4 is a half. It's already in the list. Don't put it in there again. 4 over 4 is 1. It's already in the list. 8 over 4 is 2. It's already in the list. Done. So these are the numbers I'm going to start trying. What do I mean try? I'm going to plug them into this equation until I get, when I plug in x, I get a y equals 0. So remember, pause and put this in your calculator and then come back to me. So I've got it in my calculator. You put it in yours so you can see how this works. I'm going to go straight to the table. So second graph. I'm going to try 1 and -1. Well, I think 1 and -1 have already popped up from the last problem, so the y values have changed. I need to try 2 and -2. So I'm going to plug in 2. Nope. -2. I'm looking for a 0. Nope. I'm going to try 4 and negative 4. So 4, nope. Negative 4, nope. I'm going to try 8 and negative 8. So 8, ha, yes. Okay, 8's it. So I now know that x equals 8 is a solution. All right. So guys, I could have done this by hand or on a baby calculator. On a baby calculator, I would have had to have done 4 times 8 to the 5th minus 32 times 8 to the 4th minus 8 plus 8. That would be me plugging it up here. And when I punched it into a little calculator, I would have gotten 0. But using your fancy pants calculator's table feature, it's so nice. It's so fast. All right, so now it's time for the synthetic division because I know 8 is a solution. I know it's going to divide in evenly. So I'm going to come back to where I'm keeping my work in line. I'm going to punch in 4, negative 32, negative 1, 8. Oh, I about messed that up. Look at what I did. I skipped from x to the 5th to x to the 4th. So I need a 0 for the x to the 3rd and a 0 for the x squared. And now a negative 1 for the x and an 8. Good thing I found that. So bring down 4. 8 times 4 is 32. Woohoo! Bring down 0. 8 times 0, 0. 8 times 0, 0. 8 times 0, 0. Bring down negative 1. 8 times negative 1 is negative 8. Whoop, whoop. Bring down 0. I knew I was going to get a 0 because I'd figured out that x equals 8 is a solution. So now I return to g of x, because remember, that's always what we're trying to do is to factor g of x. I didn't already have any little baby factors pulled out, but now I know if 8 is an answer, x minus 8 is my baby factor. So what's my not so baby factor? It's going to be big. 1s, x's, x squareds, x cubes, x to the 4ths. So I've got 4x to the 4th and then minus 1. That's all I've got. I need to completely factor that. Well, look, guys, do you all recognize that this is a difference of perfect squares? So normally I might go back to synthetic, but if what you've got right here is something that you know how to factor, just factor, it'll be faster. So I know 4x to the 4th is 2x squared times 2x squared. 1 is 1 times 1. This is plus, and that's minus. Now, this is quadratic, and this is quadratic. So you never do synthetic division once you get to a quadratic. The quadratic either straight up factors or it doesn't. Well, if there's only 2 terms, the only thing I could do is difference of 2 squares, but this is not a difference. This is a difference, but 2x squared is not a perfect square. So I am done factoring, okay? Now what I've got to do is find solutions. Guys, do you all see that if it's to the 5th power, I'm going to have 5 solutions? Well, x minus 8 gives me the easy solution, x equals 8. 2x squared plus 1 is going to give me my next 2 solutions. So what I have to do is say, well, if I set 2x squared plus 1 equal to 0, 2x squared is equal to negative 1, x squared is equal to negative 1/2, then what I need to do is take the square root of both sides. So plus or minus the square root of negative 1 over the square root of 2. Oh, this is a lot of work. Times the square root of 2 over the square root of 2. That's giving me plus or minus the square root of negative 2, which is the square root of 2i, over square root 2 times square root 2 is plain 2. So I got 2 messy answers. And when I say messy, I'm telling you they either have radicals or i's, or they have both. So this has radicals and i's. Now, here's the good thing, guys, with this one. When I say 2x squared minus 1 equals 0, I'm going to have x squared equals 1/2. And so it's going to be the same thing as when I had x squared equals negative 1/2. I just won't have an I. So I'm not going to do all that work again. I'm just going to say that gives me x equals plus or minus square root 2 over 2. So guys, if you get quadratic factors, quadratic means they have x squared in them, and you can't get them to factor further, your final two answers for that piece of the puzzle are going to be messy instead of neat. Messy meaning you got radicals in the answer, i's in the answer, or both. So on this one, I have radicals and i's in the answer. On this one, I just have radicals in the answer. So I get x equals 8. That's one answer. X equals the square root of 2 over 2i. X equals the negative square root of 2 over 2i. X equals positive square root of 2 over 2. X equals negative square root of 2 over 2. That's a total of 5 answers that goes with my 5th degree polynomial. Let's do the next one. All right, on this one, notice that I lead with a negative. If you ever lead with a negative, that is your GCF. Take it out first or everything gets messy on you. So I'm going to take out -1. You could just write it negative. Times x to the 4th plus 2x to the 3rd. So taking out a negative has the effect of just flip-flopping all your signs. Minus 8x squared plus 6x minus 1. It's got 1, 2, 3, 4, 5 terms. I have no idea, yikes. I have no idea how to factor something with 5 terms. So this is one where I need to start working with the rational root test. When I do the rational root test, I notice I've got the factors of 1, don't worry about the negative part, over 1. So if I've got the factors of 1 over the factors of 1, well, this is going to be easy. Do you see that the only factors of 1 are 1 and 1? So my list is just going to be plus or minus 1. Don't forget that plus or minus piece. Well, that's nice, okay? So we are going to plug it into our calculators. I've not already done that. So this is going to give you a chance to catch up with me without pausing. So I'm just going to plug in x to the 4th. I've already cleaned up a little bit, so I don't go back and plug in the original problem again. Plus 2x to the 3rd minus 8x squared plus 6x minus 1. I've got it in my calculator. I'm going to go to my table, and the only thing I need to plug in is 1 and -1. Those are already plugged in from the last problem, and I noticed that 1 zeros on my table, so 1 is my hint. So x equals 1 is a solution. Yay. So I start synthetic division with 1. So I'm going to start over here, coming back in line. So I go with 1x to the 4th. Look at what's on the inside. 2x cubed, negative 8x squared, 6x, and minus 1. Bring down 1, put up 1. Bring down 3, put up 3. Bring down -5, put up -5. Bring down 1, put up 1. Bring down 0. Whoop, whoop. I'm going fast, but I'm figuring by this point you're kind of good at synthetic, and when it's just a 1, it's super easy. So now I'm always going to come back as soon as I do synthetic. I'm going to come back to my factored form. So I'm going to go from k of x to k of x. Now remember, I already had a baby factor of -1, so I'm going to put that here. Now, since x equals 1 is a solution, I say x minus 1 here is a factor. So now my other factor is 1's, x's, x squared's, x cubes. X cubed plus 3x squared minus 5x plus 1. Okay, I see that this has got 4 terms, so I would try to group it. But 1 and 3 are not the same thing as -5 and 1, so I can't group it. What do? You go back to your rational root test, but here's the great thing. This is the list of possibilities, and that never changes. So you don't have to make a new list, you just have to make a new test. So now, guys, we're trying to break down this polynomial at this point, so put it in your calculator. So I'm doing y equals, and I'm clearing out what was there, and I'm putting x to the 3rd plus 3x squared minus 5x plus 1 on my calculator now. I'm going to go back over here to my table, and look, it's telling me once again, I don't have to type it in, because every time you type in a new equation, it automatically changes y's for you. It's telling me that 1, 0 is an answer. Again, wait a minute, can you get x equals 1 to be an answer a second time? Yes, you can, because if it's an answer a second time, it means if it's coming up twice, it's a double root, okay? So what I'm going to do is again test with x equals, not test, but do synthetic division with x equals 1. But now I'm punching in 1x cubed, 3x squared, negative 5x, positive 1, okay? Bring down 1, put up 1, bring down 4, put up 4, bring down negative 1, put up negative 1, bring down 0. Whoop, whoop. So now, after you do synthetic, you come right back to factoring. So now I'm back to factoring right there. So remember, I already had negative 1 as a baby factor. I already had x minus 1 as a baby factor, so put them down there again. Now, this one tells me that x minus 1 is a factor a second time. This tells me that x squared plus 4x minus 1 is my last factor. So this is quadratic. I don't do synthetic division anymore. Instead, I have to see if I can factor. But guys, my AC here is negative 1. And that could only be 1 times negative 1. And those are not going to add up to 4. So I just figured out this doesn't factor, but I still need answers from it. So I'm ready to start working on the solutions, or the roots, or the zeros. So I know this tells me that x equals 1 is an answer twice. So I call it a double root. To do this part, I'm going to use completing the square because 4 is even. And you might go, oh, Miss Porter, I don't want to do complete the square. If 4 is even, complete the square is faster than quadratic. So I'm going to add the 1 over. I'm going to erase this so it doesn't get in my way. I'm going to add the 1 over. So what I've got to do is condense the left, condense the right. So I see an x and a plus. Half of 4 is 2. 2 squared is 4. If I add 4 to one side, I add 4 to the other. 1 plus 4 is 5. Take the square root of both sides. I get plus or minus square root 5. Add the negative 2 over. Those are my last two answers. So guys, my answers are x equals 1 as a double root, x equals negative 2 plus square root 5, x equals negative 2 minus square root 5. So x equals 1, I count twice, so 1, 2, 3, and 4 answers. 4 answers goes with x to the 4th power. Yay, we're doing great. One more problem. Let's rock this, guys. So if I ask you to solve a polynomial equation, pull everything to one side. Zero on the other. Never, ever, never, ever, ever lead with a negative if you don't have to. So I can factor it out, or since this is equal to 0, I can divide the whole entire equation. I could divide it by negative 2, because look, negative 2 goes into all of these. So if I divide by negative 2, negative 2 divided by negative 2 is positive 1x to the 5th. Negative 12 divided by negative 2 is positive 6x to the 4th. Negative 6 divided by negative 2 is positive 3, x to the 3rd. 20 divided by negative 2 is negative 10, x squared, and that's equal to 0. Now, I can't do that if I've got it equal to y or to g of x or f of x or whatever, but if it's equal to 0, I've got a few more tricks up my sleeve. Now, do you see a remaining GCF? I do. I see the x squared. So GCF is always first. I need to keep factoring this. The problem is that 1 to 6 and 3 to 10 will not match. Groupings out of the question. Rational root test it is. So when I do the rational root test, I need to look at the factors of 10. Don't worry about the negative. What goes into 10? 1, 2, 3 doesn't, 4 doesn't, 5 does, 6, 7, 8, nope, 10. Over 1. Well, that's at least easy. The factors of this 1 right here are just 1. Well, that just says try plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. Get your calculator. So you want to get to where now that you know process, you pick up speed. So I need to, on my calculator, clear what was there. I'm plugging in x to the third plus 6x squared. Let's see here, plus 3x minus 10. Got it? Go to, look at that, guys. Look, it's already reset my y's, and I'm seeing again that 1, 0 is an answer. Oh, yes, 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 yes. That makes it so much easier. So I'm going to say, okay, I just saw that x equals 1 is my solution. So that means I come right back with the 1 and do synthetic division. So I'm going to have 1, 6, 3, negative 10. Okay, yeah, no placeholders. I was double checking. Bring down 1, put up 1, bring down 7, up. Since you are not here and I'm not walking around, the lights keep going out on me. Yippee-doo-doo. All right, guys. So now what we've got to do is go from here and rewrite our factored form. So x squared was already a baby factor. Now because 1's a solution, x minus 1 is a baby factor. And my other factor is 1x squared plus 7x plus 10 equals 0. This guy factors. So now I've got a quadratic that just straight up factors, and you might go, it does? Yeah, because look, it's 1 times 10 is 10. So my AC is 10. And if you just say positive 2 times positive 5, that gives you 10 and adds up to 7. Now, since it's 1x squared, why don't you hustle with it? 1x squared has got to be x times x when you FOIL. Well, plus 2 and plus 5 are your other two. Remember, if it's a 1x squared, you can start moving that thing along faster. So look at us. Now remember, I don't know if you can see that, the original degree was 5, so I've got to have 5 answers. Well, if x squared is a squared factor, that's telling you x equals 0 is a double root. Now, if you're confused on that, it's because you're saying x squared equals 0, x equals plus or minus the square root of 0. So that means that you're getting plus or minus 0, which means you're getting 0 and 0. So instead of doing all that, anytime you have a squared factor, you're getting a double root. This tells me x equals 1. This tells me x equals negative 2. This tells me x equals negative 5. And I've got it. Count them 1, 2, 3, 4, 5. 5 solutions. You're out. Congratulations. This was a big old lesson. I hope you did okay. Have a great day. Good luck on your homework.